Differentiation in 2 minutes. We have a function of x, which is 2x raised to the power of 4. So what it means to differentiate is that we take this 4, then we put it in the front. Then we multiply it with this part here, 2x. And now this x had an exponent of 4, right? So we just subtract 1 from it. That's the rule. So the result we get is 8x cubed. And the derivative is what we call this thing, which is denoted by dy dx. And this derivative tells us the gradient formula. Gradient formula, what does that have to do with the function? You see, when we graph this function, I don't know, maybe the graph will be a parabola. This is called a parabola. And this is the y and x plane. So over here the gradient is steep. Over here the gradient is 0. It's flat, so it's not rising or falling. This point here we write gradient in m. The m is equal to 0. So the derivative tells us where in the function the point in the function x, y, the xy coordinates that represent a flat gradient. So for that we have to put this as 0 because we want to find where the gradient is 0. Then we send the 8 there, which results in 0, and then the cube root of 0 is also 0. So this tells us that the gradient is 0 at x is 0. So when x is 0, the gradient of this is 0. I know this graph is wrong, but like this was just for representation. So then we go back to the original function 2x4, which is actually y is equal to 2x4. And then now we know that when x is 0, the gradient is also 0, right? So now we put x as 0. So the y is also 0. So when x and y is 0, a gradient of this parabola is 0. So it actually means this. Yeah.